If you missed Tuesday's class, you'll need this handout, Newton's Second Law Lab Report Sheet. You're going to write the purpose of the experiment and what you did to accomplish the purpose. We actually went over those on the day of the experiment, and you already wrote those down. If you need help, ask me for help. You will take the results from your data collection and you will write down the acceleration column of data and the net force column. You will attach a copy of your Google Sheet to this page here. And lastly, you will answer number 5. This answers the purpose of the experiment. You are describing the relationship between acceleration and net force. The purpose of the experiment was to find that out. So look at your data, look at the graph, describe it in general, and then describe it specifically. The slope is the most important thing. If you can give me a good statement of the meaning of the slope using the units, you're doing the right thing. For the back side of this sheet, you'll need to listen up here. What's the definition of a Newton? Here it is. 1 Newton is the amount of force needed to make 1 kilogram of mass accelerate 1 meter per second squared. A Newton is a kilogram times a meter per second squared. It is not a fundamental unit. It is comprised of other units. Kilogram times meter per second squared is a Newton. The units of the slope of your graph are rise over run units, or newtons of net force, divided by meters per second squared of acceleration. We want to show that these equal kilograms. It doesn't look like it would, but if a Newton is a kilogram times a meter per second squared by definition, and all of that is over a meter per second squared, all we've done is substitute in that expression for newtons right here. You can see that the acceleration units cancel out, and we are indeed left with kilograms. So the slope units of our data collection are actually simplified to kilograms, which is a mass unit. So we just answered number 7, and now we're thinking about number 8. For the class as a whole, what seems to be the connection between the slope of the net force versus acceleration graphs and the mass of the carts? That's a question mark there. What seems to be the connection? Well, here's a whiteboard for several groups in block 3. This was the mass of their cart, and this was the slope of the graph. And you can see those values are very similar, and we know that the units are the same, kilograms, so it seems that the slope is indeed the mass. So a response for number 8 should be slope of net force versus acceleration graph is equal to the mass. Number 9, based on class results, what general equation can be written that relates net force and acceleration? Question mark. Well, the graphs were linear, so y equals mx plus b is our starting point. The y-intercept of the graph is 0 because when acceleration is 0, net force is 0. We don't have y, we have net force, and on the x-axis is the acceleration. And the slope depended on the group. Everyone had a unique slope, but the slope was the mass. So we'll write this equation as a general equation, correct for everyone, as net force equals the mass of the object times its acceleration. Notice mass here is not that m, that is just the m for slope in your algebra book. And now this is mass, and I do want to abbreviate this as net force equals mass times acceleration. But realize that m is for mass and not just a general symbol for slope. This equation that we just came up with is called Newton's second law. Newton's second law is the name for this general equation.